Okay, this is just on the standard linear relationship. So this is just about sketching lines. Now, previously to sketch lines, you've used tables of values. So if you've got y equals 2x minus 4, then, you put in minus 1, and you go 2 times minus 1 minus 4. 2 times minus 1 minus 4, which gives you minus 2 minus 4, which is minus 6. That's where that minus 6 comes from. If you put 0 in there, you go 2 times 0 minus 4, which is minus 4. 2 times 1 minus 4. So you do the 1, which is minus 2. And you can probably keep filling the rest of them out because you notice what's happening. It's going up by 2. The next one will be 0. See how it goes up by 2? Even if you did that one, it would be 2 times 3 minus 4, which is 6 minus 4, which is 2. That's the y value. Then you go up by another 2 and up by another 2. I want you to notice a couple of things with this. Is that when x equals 0, that's the y-intercept. Then y equals minus 4. And that number at the end of the equation there, you've got y is 2x minus 4. That number there is actually where it intersects the y-axis. The other number, which is the 2, so that 2, that there, that's what it's going up by each time. And that's actually a gradient, because what this is telling you is like if you go to your y-intercept of minus 4, for every 1 you go across, you're going to go up 2, because it's positive 2. Every 1 you go across, you're going to go up 2. And that's basically what your line will look like there. And that there, the 2 up and the 1 across, the 2 on the 1, that is actually your gradient of your line, because it is your rise. It'll be your rise on your run, which is the 1. So the 1's run. The run is 1 and the rise is 2. Okay, so if you look at these here, so what we're going to do is plot the lines, define the linear relationships, find the coordinates of the y-intercept and calculate the gradient. Now, I'm not going to do that using a table of values because we can do it in another way. And that's kind of what I want to show you. So if you've got... if you put in y equals 0, you're going to get where the x-intercept is. So you can put 0 is 2x plus 1. And then when you bring the 1 across, you get minus 1 equals 2x. So 2x equals minus 1. If you divide by 2, you get x equals minus 2. So that means it will cut the x-axis at minus 1/2. And then if we now get where it cuts the y-axis, so you put in x equals 0, you get 2 times 0 plus 1. So you end up with y equals 1. So if you go up to 1, that would be that there. And then if you just draw a line through those 2 points, okay, that would be sketching the line. Okay, so now the gradient of that line is equal to, if you look at this, that would be 1/2. Right? So 1/2, because the rise is 1 and the run is 1/2. So 1/2, 1 divided by 1/2, how many halves go into 1? That would be 2. And you notice that the number in front of the x is 2. And the y-intercept is 1. So it's this number here. That's your y-intercept. So what I want you to see from this is that when you have an equation of a line, the equation of the line is in the form of y. Sorry, I'm just going to do a better picture there. Y equals the gradient times the x plus the y-intercept. Okay, so the number in front of the x, so say I have 3x minus 2, the number in front of the x is the gradient. And this number here is the y-intercept. We do have symbols for this. We usually say it has mx plus. Actually, in the new syllabus it's C and on the formula sheet. Where M is the gradient and C is the y-intercept, or where it cuts the y-axis. Okay, so let's just pick out another one. Let's look at that one there. Okay, so I'm going to sketch that one, and we're going to sketch it using the gradient. I'm going to sketch it using the x and y intercepts. So it is y equals minus 2x plus 1. So you put in x equals 0, and you get y is minus 2 times 0 plus 1, which is 0 plus 1, so y is 1. And y equals 0, they put 0 is minus 2x plus 1. Minus 2x plus 1 equals minus 1. Minus 1 minus 1. Minus 2x to get rid of the minus 1. Minus 1 is minus 2. Divide by minus 2, and x will equal 1. So that means that when you go to sketch this line, it goes through 1 on the y-axis, and it'll go through... Whoops, I just spotted a mistake here. That should be minus 1. Because it is actually, if you look at it, we'll just go back up here, that's minus 1. To go on that side there's my other mistake. That was equal to 0. So when you take away minus 1, you get minus 1. Minus 1 on minus 2 will actually give you 1/2. So that means that it goes through 1/2. So then if you sketch the line that goes through that, that's what it looks like. You can see that the y-intercept is equal to 1, which just matches that number there. And you can see if you did the gradient is the rise on the run. So the rise here is 1, the run is 1/2. And if you did 1 divided by 1/2, it's 1 times 2 on 1, because remember, when you divide, look to the right side, flip and multiply. So you end up with 2. So the gradient is 2. So notice how the equation, notice that the number in front of the x, which is that one, is the gradient. Okay, so that's going to be minus 2x plus 1. Okay, and maybe if we just look at one more. So this one here, we know that, I'll just put it in the right order, minus 2x, and it'll be positive 3. I know here that the gradient is minus 2 and the y-intercept is 3. Okay, so if you put in x equals 0, you get y is minus 2 times 0 plus 3. You could draw up a table of values and do this as well. You could go x and go 0, 1, and then 2. Takes a little bit longer, but you could do that. The more advanced way is to use x and y-intercepts. So put in y equals 0, and you get 0 equals minus 2x plus 3. Bring that across, so you get... actually, I'm just going to swap the sides. So minus 2x plus 3 equals 0. Take away 3, minus 2x equals minus 3. Divide by minus 2, so x equals 1.5. So what's happening here is we have a couple of things. It intersects the x-axis at 1.5, and it intersects the y-axis at 3. So let's plot that. So go 1, 2, 3, 1, and we need to get to minus positive 1.5. Okay, that's 2 and 1. So positive 1.5, and then let's go and let's put a line through there, through those 2 points, and there's your line. So that's just using the x and y intercept method. Okay. If we look at this then, the number in front of the x, when we answer this, the number in front of the x is a 2, the gradient is 2, the number by itself is 1, the y-intercept is 1. So this is minus 2, gradient is minus 2, y-intercept 1, y-intercept 1. This one's back to front. It's minus 3x plus 4. So that should be minus 3 for the gradient, and 4 for the y-intercept. 4 and 4 for the gradient, minus 5. This one here, the gradient would be 5, because that's what's in front of the x. And there's nothing here, so that's 0. This one here, wrong way around, so go minus 2x plus 3. Gradient's minus 2, y-intercept is 3. Okay, so a linear equation can be written in the form of y equals mx plus c. M will be your gradient, and c will be your y-intercept, or where it cuts the y-axis. Therefore, the coordinates of the y-intercept are 0, c. That's what, because when you put in 0, you get m times 0 plus c. So m times 0 is 0 plus c. Okay, so with this one we have to look at which of these have a gradient of a half, y-intercept of 0. Well, they've got, is that meant to be minus 0.7? They're minus 0.7 and a half, so that one matches. A gradient of 10, so that's the gradient's 10, y-intercept 16. So that would be that one. A gradient of 0.7, y-intercept of 9. That's that one. This one here, you need to simplify it. Go 18 minus 6 is 12. That's a trick. Okay, so it's a gradient of 15. Oh, not 15, 5. Gradient of minus 5, y-intercept of 12. Oh, they've done it again. So you've got to simplify that. Plus 2 minus 12 is minus 10. All right, so just be wary that you've actually got to get it in that form. So you've got to simplify first. 3x minus 10. So a gradient of 3 and a y-intercept of minus 10. That would be that one. This one here, a gradient of 50, y-intercept of minus 80. Gradient of 3, y-intercept of 0. So where would that be? That's that one. And gradient of 15 on 18. 15 on 18 actually simplifies, so that's 5 on 6. So that would be that. And the y-intercept 0, because there's nothing just there. Okay, so that's why the y-intercept would be 0. All right. Now this one's, I've made some another video, and we'll do a little bit more work on this. But if you want to actually find the equation of this line, okay, what your steps are, first thing you got to do is look for the c. So c is the y-intercept. So if you come here, that means the c would be minus 5. The gradient, now you're going to need a triangle to draw the gradient. So you need to know some points that it actually goes through. Now what I might do, because if I do that, that will give me a good point. I can see it's right, this will be right on the line. You don't want part ones because you can't read them. Now that's 1, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10. So the gradient there is the rise on the run, which is 10. It is also a negative because it is going down, and you can make an n out of it. So it's y equals minus 10x plus minus 5. Okay, so I'll just put a couple here, and we'll just run through just finding the gradients. So say that's 4, 3, 0, minus 2 and 3. Okay, so for this one, the gradient, which is m, is the rise on the run, which is 3 on 2. Now notice that I'm looking at the length 2, and this is the rise, and this is the run. I am not interested in whether it's negative or not. You could do it here, and you would still get 3 on 2. Like even here, 3 on 2. That sign is just where it's plotted on the axis, but it means what you're really interested in is that space there, which is 2, and that space there, which is 3. The y-intercept is equal to 3, because that there is where it actually intersects the y-axis. So that will be 3. So this is also a positive slope. So it's y equals mx plus c. So that means it'll be y equals 3 on 2x plus 3. Okay, with this one, the gradient is rise and run. So that's 3 on 4. And the y-intercept, which is C, is 3. So we used to do B, now we're doing C. So y equals mx plus C. Now, I have made one little mistake. Will you spot what that is? That's right, that's a negative gradient. So that actually needs to be minus 3 on 4. So it's y equals minus 3 on 4x, and then plus the y-intercept, which is 3. So it's that's your two equations.